Hello everyone, in this video I am going to explain the function of Linux and graphically, and also the inverse of it, which is ex, and the graphical explanation of it. From the previous video I explained that the graph of Linux is almost like this. So we have Linux, this is the graph of Linux. So we know that the graph is increasing because as we move, as the value of x increases, the value of y also increases too. We also know that the graph is concave downward, because if you look at it, concave downward. So when you say the graph is increasing, in other words, we meant that the first derivative test, for example, when we have this, the first derivative test, f of x is greater than 0. And by saying that the graph is concaving downward, it means that the second derivative test of the Linux is negative. So it means that when we take the first derivative test of Linux, which is 1 over x, the graph would be positive. The result of the first derivative test is always positive. So it means that the graph is increasing. But when you take the second derivative test of Linux, so the graph and the result would be always negative. So it means that the graph is concaving downward. So this is for the concaving and increasing. So for the domain means the value of x's. So this is the domain. For the domain, we need to put our consideration on the value of x's. It starts from 0, but we never approach 0. So 0 is not in the domain of the function. It starts with the 0, but we don't include 0 because it never approaches 0. So it starts with 0 to a point. But we know that at this point this goes to the positive infinity. So it starts from 0, but not included, to positive infinity. So this is positive infinity. This is the value of the x, or the domain. For the range, we need to consider the value of y. So we have y equals to, it starts from negative infinity to positive infinity, because the graph is continuous at all the points, and the graph starts from negative infinity to positive infinity without stopping. It's continuous, so it is all real numbers, or negative infinity to positive infinity. This is the graph of something else. For the limit, when we try to take the limit of fx, which is Linux, we know that fx is Linux. When x approaches 0 on the positive side, okay. When we try to take the limit of Linux, when x approaches 0, when we approach 0 on the graph, we know that the value would be negative infinity, because we don't know the result, but it goes to the negative infinity. So the value is negative infinity. But when we try to approach it from limit fx, when x approaches positive infinity as well. When we approach to the positive infinity, the result will be positive infinity, because it goes to positive infinity, and this goes to positive infinity too. So it will be positive infinity. We cannot say that find the limit of fx when x approaches 0 from the left hand side, because the graph does not exist here, so the result does not exist. Uh, for this one, yeah. And I think this is a brief explanation of the graphical explanation of Linux. Now, we need to talk about the inverse. We know that when we take the inverse, there must be several conditions that need to be exist. The first one is that the graph must be either increasing or decreasing, because in this condition, the graph would be one-to-one. For this one, we explained that the graph is increasing because the first derivative test would be greater than 0, and from the graph we can be sure that as the value of x increases, the value of y increases too. So we know that the graph is one-to-one, and we also know that the graph is continuous. So we can surely say that the over the domain, the graph is continuous, and the graph is either increasing or decreasing. So it means that the graph is one-to-one. So when the graph is one-to-one and continuous, we can say that the graph is invertible. In other words, we can take the inverse of the next, because both the conditions are existing. This is one. And the second one is that over the domain, the graph is continuous. So we can see that it is invertible. So for the inverse function of Linux, I prefer explaining it again on the graph. For example, when we have the graph, this is the graph. This graph. There's a theory said that, for example, when we take the inverse of a graph, for example, when we try to take the inverse of this, the graph of the inverse function would be around the reflection of this graph around the line of y equals to x. So it would be around this line. So when we have the line, this is our line of y equals to x. So our graph is already here of Linux. And when we take the inverse of it, it will be reflected around the line of y equal to x. So it will be moving to somewhere like this. So this is the fx. This is the inverse of this, because we reflect this one to the line of y equal to x. So again, I need to also explain the graph. For example, the first one that we need to be sure is that this graph is also increasing. So it is increasing too. Increasing, because as the value of x is increased, the value of y is also increased too. So it means that the first derivative test of the inverse function is positive. But as we consider, the graph of the inverse function is concaving down. The graph of the function is concaving downwards, so it means that the graph of the other function is concaving upward. So it meant that the second derivative test of the inverse function is positive too, because the graph is increasing and the second derivative test is positive. So when the second derivative test is positive, it concaves upward. This is for the graph. And then we have something else. So we have something else. Yeah, for the domain. Okay, for the domain, as I explained, domain means the value of the axis. We have what? The domain starts from negative infinity, the values of x, and this is for the value of y. It starts from negative infinity to positive infinity because this goes to the positive infinity. So the domain is from negative infinity to positive infinity. Or we can say that all real numbers. But the range, this is the range. The range starts from the positive side. So it doesn't exist below the x y equals to 0. So we say that it starts from 0 and it never approaches 0 to positive infinity. Okay, so if you consider this too, whenever you take the inverse of any function, the domain of the original function is the range of the inverse function. This is the domain of the original function x and 0 to positive infinity, and it would be the range of the inverse function because it is about the y equal to x. And also, whenever you take the inverse of a function, the range of the original function would be the domain of the inverse function. We have this as a range of the original function, but there it is the domain of the inverse function. This is a very important point that you need to consider all the time that you take the inverse of any function. The domain and the place of domain and range are flipped when you take the inverse. So the domain would be the range of the inverse function, and the range would be the domain of the inverse function. And when we take the limit of this, when we take the limit of when x approaches positive infinity is what? Infinity if x is when x approaches positive infinity, it is infinity too. But when x approaches 0, when we try to approach 0 from both sides, it would be 1. Well, this point is 1. We know that this by definition. And when we try to approach lim x approaches negative infinity of the inverse, so it would be negative infinity. It would be 0, yeah, because when we try to approach it from the negative infinity, it would be 0. So you know that these two are flipping. When we try to approach negative infinity, in the original function, we try to approach 0, so we get negative infinity. But here, in the inverse function, we try to approach negative infinity, so we get 0. So it is all about the flipping of the domain and the range. As I mentioned, it's all about the flipping of the domains and ranges that when we take the limits, they will flip it also. Yeah, I think I just forget something. Yeah, from the graph, we can conclude that this graph is e to the power of x. So we concluded that the inverse function of ln x is e to the power of x. And whenever we have ex, the inverse would be ln x. So I think it's all about ln x and its inverse graphically. I hope you enjoyed the video and I hope you get benefit from the video. I have planned to explain more about ln x and ex in the following next videos, how to take the derivative and integration of ln x and ex's, and how to take the integration and derivative of ln x's and of logarithmic functions and exponential functions that the base is not e, so they are not natural.